Dear students, in the previous lecture we have discussed about ruby laser and its disadvantages. To overcome the disadvantages of ruby laser, that is solid state laser, a gas laser, which is the first successful laser, has been designed in the year 1961. Let us first see the construction and working of helium neon gas laser. In the gas lasers, the combination of the two gases will be used, and the combination of the two gases is selected in such a way that the energy values of highest energy levels of both the gases should be same. Like that, the important gas combinations are helium neon and nitrogen carbon dioxide. At present, now let us look at helium neon gas laser. It consists of a glass tube of length 50 centimeters and of diameter 1 centimeter. It is filled with the combination of helium and neon gas in the ratio 10:1. That is, for every 10 atoms of helium, there will be 1 atom of neon. This glass tube is sealed at both ends, and two plain mirrors are attached to the glass tube. These two are perfectly parallel to one another and perpendicular to the axis of the glass tube. One of these two mirrors is completely silvered, so that it is 100% reflecting, and the other mirror is partially silvered, so that it is semi-transparent. And two electrodes are connected at the two ends of the glass tube. They are in turn connected to the two terminals of the high voltage source to create or to establish discharge in the glass tube. Now, when the discharge is created and electrons and ions are created in the gas, and these two particles are accelerated in opposite directions. And helium atoms, when compared to the neon atoms, are less stable and are having less weight. They are light when compared to the neon atoms in weight. So when the fast moving electrons collide with the helium atoms, they transfer their complete energy to the helium atoms, and they excite the helium atoms to their highest energy level. So the helium atoms will be excited to the highest energy level, and from this the energy level diagram we can understand there are two energy level diagrams. One belongs to the helium, the other belongs to the neon. So we can see in the helium energy level diagram, we can take the lowest energy level as H1, then the second energy level is H2, then the third one is H3 instead of 2s1, 2s0. Okay, they are all the energy levels of 2s energy levels in helium atom. We can take H1, H2, H3. Similarly, in the neon, the lowest energy level is E1, and the next energy level is E2, that is shown as 1s. Then the E3, that is shown as 2p. Then E4 is shown as 2s. E5 is shown as 3p, and E6 is shown as 3s. Now these are the energy level diagrams of both helium and neon atoms. Now helium atoms are excited to the energy levels H2 and H3, or we can say in the diagram 2s1 and 2s0. They are present in these two energy levels, and these two energy levels are more unstable, and the helium atoms which are present in these energy levels will be fully excited and having more energy. They cannot take transition directly onto the lower energy level by emitting the energy. This kind of transition is forbidden. It is not allowed in this laser. Therefore, the helium atoms, they transfer their complete energy to the neon atoms through collisions and excite the neon atoms to the energy levels 2s and 3s, or E6 and E4 and E6, or 2s and 3s. It is just shown in the figure, right? The energy levels 2s and 3s of neon atoms are filled with the neon atoms which are excited by means of collisions. So now the neon atoms are excited to the 2s and 3s energy levels. These 2s and 3s energy levels are metastable states. So their lifetime is more, and in due course of time more and more number of neon atoms are accumulated or gathered in these two energy levels. In due course of time, a population inversion state is achieved between the energy levels 3s and 3p, and 3s and 2p, and 2s and 2p. The population inversion state is achieved between these energy levels. One is between 3s and 3p, the other one is between 3s and 2p, the last one is between 2s and 2p. So there is a possibility for the transition to take place between these energy levels. So there are three transitions that can take place. The one is between 3s and 3p, the other one is between 3s and 2p, and the last one is between 2s and 2p. So when the transition takes place between 3s and 3p, the energy that is emitted will be in the range of infrared, and the wavelength of such light is 3.39 micrometers. Similarly, there will be transition which is triggered by means of spontaneous photons which are emitted by few atoms which will take transition spontaneously. That the energy will be emitted between that when the transition is taking place between 3s and 2p. This transition is very important, which will be useful for laser action, and the light that is emitted during this transition is called as the laser light of red color and of wavelength 632.8 nanometer or 6328 angstroms. This is laser light. There is another transition that is between 2s and 2p, and once again the light that is emitted will be in infrared region of wavelength 1.15 micrometers. Now the most of the atoms are present in the 2p energy level. The transition is possible between 2p and 1s, and all these transitions are spontaneous transitions and they are fast radiative transitions. The light that is emitted by the atoms during these transitions will be highly incoherent. Therefore, the light will be emitted in different directions. So it will not be considered as a laser light and useful light. Now all the atoms will come and gather at the energy level 1s, which happen to be once again metastable state. In due course of time, once again a state called population inversion state is achieved between the lowest energy level of neon and 1s state. So there is every possibility for the transition to take place between these two energy levels, and light that is emitted will be once again the coherent light, but this light will disturb the light which is already emitted during the transition from 3s to 2p. So this transition should be avoided, or this radiation should be avoided. Transition can't be avoided, but we can avoid the radiation. So for that, the dimensions of the tube are made to be very narrow, so that when the atoms having energy in the 1s energy level drift, they collide with the walls of the glass tube and lose their energy to the walls of the glass tube and take transition to the lower energy level without emitting any radiation. Therefore, all the neon atoms will reach now to the lowest energy level. So this is a continuous process every time. So during discharge, the helium atoms are getting excited and they are transferring their energy to the neon atoms. In turn, the neon atoms are getting excited to the highest energy level. Then the transition is taking place between the levels and the laser light is being emitted. So here the important thing is the helium and neon gas are selected because they are having the highest energy levels of same energy values. Then only the transfer of energy from atoms of one gas to the atoms of the other gas will take place. So this is about the helium neon gas laser. In the next class, we can study about the semiconductor laser, which is very popular laser, which is being used nowadays in everywhere, in the research laboratories, in industries, in the medicine field, which is very, very important. That we are going to discuss in the next class. Thank you very much.